Okay, can you just go to the next page now? Okay, next topic now. So in this first lesson of the new chapter, we were looking at Newton-Raphson method for finding the root. So we're going to have a look at a different type of equation problem now, called fixed point. So for example, what we've learned so far is how to solve this. And this is the problem of finding the root. What we're going to look at now is how to solve this, which is called a fixed point. And I'll give you an example. So for example, if I had fx, well, here's an easy one, fx equal to x squared. What value of x should I pick so that f of x is the same as x? Any ideas? 1 would do it, yeah? So what's f of 1 equal to here? 1. Any other numbers? Yeah, f of 0 equals to 0. Okay. Let's have a look at one that's a little bit more difficult. So let's say I had f of x, I don't know, equal to 3x plus 1. So what I'm trying to do here is find when f of x equal to x. So that's when 3x plus 1 equals x. So that's when 2x equals minus 1. So that's when x equals minus a half. So you can see this for yourself. If you have f of minus a half into 3 times f minus a half plus 1, if you type that in the calculator, you do get minus a half. So you have, therefore, x equal minus a half is a fixed point of fx. So what's exactly the meaning of these fixed points? Well, they're interesting because they are numbers that when you put them into the function, they don't change. So if you put minus a half into f, out comes minus a half. So they're special numbers, numbers which are left unchanged by the function. So the problem now is, how could we find the fixed point for a function? That is, how can we find this number that is not affected by the function? Sometimes it's easy to find it, and sometimes it's quite difficult to find. So the process I'm going to show you is a bit like Newton-Raphson process for finding it. Okay, can I scroll down? Yeah? Okay, so for example, this is our problem. Our problem is we want to solve this. But you realize, well, that's the same thing as trying to solve this. That's same as that. And if you call this here on the left G, then your problem is basically you want to solve this. And what process can we use here? Well, we can use Newton-Raphson because now we've changed the problem into finding a root. So Newton-Raphson says xn plus 1 equals xn minus gxn over g derivative xn. But we know what g is. G is fx minus x, and the derivative will be f derivative xn minus 1. The derivative of this g here. Here's the g. Now, you might think, okay, so that's it. That's the new formula for our fixed point. We can use this formula to find the fixed point, and it looks a lot like Newton-Raphson, but in fact, we can simplify this formula. So what I'll do is, I'll write this as xn plus fxn minus xn over 1 minus f derivative xn. So I'm just putting the minus down below. xn plus fxn minus xn times 1 over 1 minus f derivative xn. Now, what I'll do next, there's a formula I'm going to use here which comes all the way back from semester 1, so I'll just go to the side to remind you of the formula. So you might remember from semester 1, 1 over 1 minus or is equal to 1 plus or squared plus or cubed, etc. That came from the chapter on geometric, arithmetic and geometric sequences. So I'm going to use that formula here, where this here is like or. So I get multiply 1 plus f derivative x plus f derivative x squared, etc. Now what we can do we can just take the first two terms instead of taking all of the terms. And of course the price I pay is that my answer isn't exact, it's only approximate now. But that's not a big price, because what's happening is I'm using this formula many times. And each time I use the formula I move closer to the answer anyway. So the price I pay is a rather small price. I just move to the answer a little bit slower, that's all. So it's not a big price. Yeah. You have a question? Okay, can I continue? So if I multiply this out, I get xn plus fxn plus fxn f derivative xn minus xn f derivative xn. Okay. Did I multiply that? Okay. fxn times 1 is fxn. Which one? Oh, here. Yes, I did. fxn times that is that one. Oh yeah, I only have 3 terms. I left one out. Which one did I leave out? Yeah, so minus xn here. That's good, because that piece there will cancel with that piece there. So this equals fxn plus fxn f derivative xn minus xn f derivative xn. Okay. Now what I can do next is I can take the derivative out, and I'm just left here with fxn minus xn. Now let's just remind ourselves, what are we trying to find here? We're trying to find when fx is equal to x. So what do you think about this number here? Will it be big or small, or what will be its value? What do you think? It should be 0 or nearly 0. In fact, it's 0 when we get to the answer, and it's nearly 0 when we're near the answer. So this piece here is actually very small. And just like earlier, I'll throw away that piece because it's small. It won't affect my formula too much. So now I end up with this. Now this is actually rather amazing if you think about it. The formula for finding the fixed point is actually the function itself. We'll have a look at an example of that. So when you're ready, I want you to put your calculator in radian mode. Do I still have my Office program open? No, I don't. Okay, so you have your calculator in radian mode? Yeah. Okay, so let's do a first example. What is the fixed point? I think let's do cos first. So let's pick a number to guess to start with. So where will we start? Let's start with 0. Is cos 0 0? No, cos 0 is 1. The formula says the next value is just f of the value you're guessing. So we start off with x1 equals 0. x2 would be cos 0, which equals 1. x3 would be cos 1, which equals, what's that? 0.54. Then x4 will be cos 0.54. Now what I'll do is I'll just do this in the program here. So here's the number of steps. 1. Here's my guess. So I started off with, what was it, 0. And here's my fxn, which is cos that number. So our next one was, I must have done something wrong here. We started with 0. Is this in radian mode? Oh, there we go. Was the next number here 0.857? Yeah. Okay, great. So I'll just use Excel here to do it a few times. So if I go, let's go to 20. So if you type in, I'd like you to type in on your calculator cos of this number at the bottom here. I have it highlighted there. Type in cos of that number. Sorry, you might not be able to see it. So basically, nearly the same number as what you put in. So you found the fixed point for cos. Cos of this number is the same number. Now I can actually make it more accurate if I do it many times. So let's say if I go to 100. 0.7390851332. If you type that one in, it should be exactly the same. Yep. So this process is rather simple. What's happening is you have a function, you make a guess as normal, you put your guess into the function, and the number you get out is the next guess you should try. And this process repeats itself. I want you to try it again for this one, x squared. And I want you to start at 0.5. Yeah. Which part now? Here? So I want you to try for x squared and start at 0.5. Yeah, you got it? Yeah. So I want you to try this one. And while you're doing that, I'll just get the program ready here to do it. Okay, so what did you get as your answer? 0, which we knew was one of the answers, yeah? And if I look, and if I do it here, if I do it 10 times, oh, well, it gets to 0 really quickly. In fact, it got there nearly after 4, yeah? Now, I just want you to do the same thing, but this time, instead, start at 1.5. Something's gone wrong, hasn't it? It gets bigger, doesn't it? I can see in Excel that it basically becomes too large at step 12. So you might have thought, if I start at 1.5, I should end up with 1. Because when I start at 0.5, which fixed point did I move to? I moved to 0. And I said there was a second answer. Well, the second answer was 1. So you thought, if I start at 1.5, maybe I should get to 1. But you didn't. And that's because one restriction of this method is it can only find what's called attractive fixed points. These are points which you can move in on. In the example I did with the x squared, here is one fixed point, and then here is the other fixed point. If you were to start here at 0.5, you end up moving to 0. But when we start at 1.5, did we move towards 1? No, what instead happened? We moved away. So this one is called attractive fixed point, and this one is non-attractive fixed point. Yeah, how can we tell the difference? Why did one work and the other didn't work? Well, it goes back to our formula, our proof, if I go back for a moment. First thing is, we need to start near the answer. Now, is 1.5 near 1? It is, so that's fine. But there's a second thing here which I didn't say yet. This formula here I used from semester 1, there's one important restriction on this formula. I wonder if anyone remembers it. It's the R must be between -1 and 1. So if I go back here, it basically means this formula only works if the derivative is between minus 1 and 1. Now if I look at the example I just did, what's the derivative here? 2x. And what did I start with for x? 1.5. So what's that? That's going to be 3, which of course is more than 1. This isn't something you have to worry about in the exam though. In the exam, they'll always have you find an attractive fixed point. In fact, in the syllabus it says students do not need to worry about attractive and non-attractive, okay? But I think it is important to say that this formula only works to find attractive fixed points, which basically means it only works when the derivative is small, less than 1. Which it will be guaranteed in the exam. In the exam, they won't have this situation that you just did for me. This will not happen in the exam. If this does happen in the exam, it means you've made some mistake. It should not happen in the exam, okay? Now we just have to check to see if there's any other types of problems with that lesson. No, that's really it. Yes. Say again, this is 0.5? How does it reach the fixed point? Well, if you look here, Joshua, hey, look up, guys. If I calculate 0.5 squared, what do you get? Yeah, and 0.25 squared, what do you get? Yeah, and keep squaring your answer. Where is it moving to? Minus 27. What are you talking about? You're not speaking down to you. It's a pity you missed so many classes, Joshua. You could be a good student if you were here more often. Right, for about 10 minutes I want you just to try the questions on the fixed point worksheet. So try those for a few minutes.